Hello, third grade scientists. It's Miss Prickett again. I love that I get to team up with your teacher to help teach you some cool things about science. Today's investigation is all about magnetism, okay? Now, if you remember from the beginning of the year, we learned a little bit about magnetism when we were studying matter, right? We learned that it was a force. Even before we were learning about what forces were, we knew that magnetism was a force, and it was a force that worked with magnets and certain metal objects, right? Well, today we're going to investigate exactly what kind of a force magnetism is, because we know that a force has to be either a push or a pull, right? So I wonder which one magnetism is. Well, we're going to find out today. So the first demonstration I want to do for you, I have this paper clip here. It might be kind of hard to see, so maybe if you like zoom in or something, you can see it better. But there's a paper clip attached to a string, and that string is taped down here to the table, okay? So I've got a paper clip there on my table, and I've got one of these bar magnets. See, it's a magnet, all right? So I am going to move this magnet closer and closer to the paper clip slowly, and I want you to watch what the paper clip does. I know it's kind of hard to see, but I think you can see it right there, okay? So as we get a little closer and a little closer, watch that paper clip. Watch the paper clip. Did you see that? Did you see that? Let's do it again. Watch closely. Think about what it's doing and what the magnet is making it do, what that magnetism force is doing. Okay, so how would you describe what just happened? What do you think? Okay, so the paper clip moved. Did it move closer to the magnet? Yes, it did. And what kind of a force is it if it brings something closer? Do you remember? That's right, that's a pulling force. So magnetism can be a pulling force. It's the force that pulls objects like paper clips towards a magnet, right? Now I'm going to show you something really cool with this paper clip and this magnet, okay? And I hope that you can see it okay. All right, so I'm going to start out with the paper clip attached to the magnet, and I'm going to pull it away just a little bit, ever so slightly. And then eventually, let's see, oh my goodness. Let's see if I can get it to show you here, okay? I'm gonna pull slowly, 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 slowly. Oh man, that didn't work. So what I'm gonna do is I'm gonna keep trying, but I'm gonna see if I can get the paper clip to float, okay? To not be touching the table and to not be touching the magnet. So we'll try a couple more times here, and then we'll see if we can get it, okay? So I'm moving the magnet slowly away. And if you have a magnet and a paper clip and a string at home or wherever you are, you can try it. Oh my goodness, it's working. I don't know if you can see it. Oh, let's see if I bring the camera a little bit closer, if you can see, okay? Woo, that's really close, isn't it? But now I need to angle it down to the table. There we go. Let's see if we can see what's happening here. All right. Yeah, I think you can see that. Oh, it did it for a little bit. Let's do it again. Oh, do you see that? It is not sticking to the magnet at all. It was floating in between. Let's try one more time. Hopefully you can see it okay. All right, the magnet is officially not touching the paper clip. Do you see how the paper clip is wiggling there? So it's like the paper clip is floating in space. Isn't that fascinating? The pulling force of the magnet was so strong that it kept the paper clip in midair because that paper clip was so attracted towards the magnet. Fascinating, isn't it? Well, here we have one more demonstration, right? So we already know that magnetism is a pulling force because it pulled that paper clip towards the magnet, right? Here we have some other magnets. These are ring magnets because they look like little rings, and they are stuck together, right? I'm gonna slide them down on top of this pencil, just like that, right? Well, I wonder what's gonna happen if I just flip one of the magnets. Make a prediction in your head. Use what we already know about magnets and see if you can predict what's gonna happen, all right? You ready? Here we go. Look at that. Look at that. We know that magnetism is a pulling force, but if I try to force that magnet down back on top of the yellow magnet, it gets pushed away. It's getting pushed away. So can we also say that magnetism is a pushing force? Oh my goodness. So magnetism is both a push and a pull. When a magnet is close to certain types of metal, like a paper clip, it will attract or pull the paper clip towards the magnet. And when two magnets have opposite sides close together, they also pull towards each other. But if the magnets have the same sides facing each other, they will push or repel. So let's see if I can get all of these magnets, there's a lot of them here, to repel or push against each other and look like they are floating. Nope, I think I need to flip it this way. Oh, wrong way. Oh, did you see that though? It's gonna pull that orange magnet up. Oh, magnets are so cool. All right, let me flip it the other way. There we go. And let's try this one. Oh, look at that. And let's try this one. Oh, wrong way. One more. There we go, and last one. Oh, wrong way again, but did you see how it pulled that green magnet up? Let's do that one more time. Watch it, watch it, watch it. Oh, it pulled the green magnet up. Now let me flip it over. There we go. Oh my goodness. I've got all these magnets that appear to be floating, but they're not actually floating. They're being pushed away by the magnetic force of the magnet underneath it. Isn't that cool? So today we discovered that magnetism is a force, right? But it's a force that both pushes and pulls. So it's a very interesting, very cool scientific force, and I hope you enjoyed these demonstrations.